Deep in the heart of the Namib Desert, one of Earth's oldest and driest landscapes, lies a mystery that has puzzled scientists and captivated travelers for decades. Imagine flying over a seemingly endless sea of red sand and golden grass, only to see the ground below dotted with millions of perfectly circular, barren patches. These are the Fairy Circles of Namibia, a breathtaking natural phenomenon that looks like something straight out of a fantasy novel. For years, people have whispered tales of their origin. Local legends from the Himba people speak of their supreme being, Mukuru, leaving these footprints on the earth. Others believe they were created by gods, spirits, or even dragons, breathing fiery patches onto the land. It's easy to see why. The sheer scale and perfect geometry of these circles feel otherworldly, as if a divine artist meticulously arranged them across the desert canvas. These circles can range from just a few feet to over 40 feet in diameter, and they appear and disappear over a lifespan of about 20 to 60 years. What's truly bizarre is that inside each circle, the ground is completely barren, while the edge is often fringed with a ring of taller, healthier grass. It's like a tiny, self-contained ecosystem with its own set of rules. So what's the real story behind these enchanting patterns? For a long time, the scientific community was stumped. The first major theory to gain traction pointed to a tiny, almost invisible culprit: the sand termite. The idea proposed by biologist Norbert Jürgens was that colonies of sand termites, Samotermes alacarus, were munching away on the roots of the grasses from below. According to this theory, the termites create a permanent underground nest, clearing the vegetation above to create a central point. This barren patch then acts as a natural water trap. Rainwater, instead of being absorbed by plant roots, soaks deeper into the sandy soil, creating a subterranean reservoir that the termite colony can rely on during the long, harsh, dry seasons. The lush ring of grass around the edge benefits from this extra moisture, creating the distinct halo effect we see. Essentially, the termites are brilliant ecosystem engineers, sculpting the landscape to ensure their own survival. It's a fascinating example of how a tiny organism can have a massive impact on its environment. But just when we thought we had it all figured out, another compelling theory emerged, and this one didn't involve any animals at all. This second hypothesis, championed by scientists like Stefan Getzen, focuses on the plants themselves. It's a story of intense competition in a place where resources, especially water, are incredibly scarce. This theory is called self-organization. Here's how it works. In the arid Namib, rain is a rare and precious event. When it does fall, the grasses immediately start to grow. But the sandy soil can't hold water for long. Stronger, more established plants develop extensive root systems, pulling in as much water as they can from their immediate surroundings. This creates a zone around them where there isn't enough water for new seedlings to survive. Over time, this intense competition for water leads to the death of weaker plants in the center of a patch, creating a barren circle. The water that would have been used by those plants now becomes available at the edges, allowing the grasses on the perimeter to thrive. So the circles aren't created by an external force, but are a natural pattern that emerges from the plant's own struggle for life. It's a beautiful, if brutal, example of survival of the fittest playing out on a massive scale. For years, the scientific world was divided. Was it the termites or the plants? Team termite versus team plant. Researchers on both sides presented compelling evidence. Proponents of the termite theory found termite nests and activity consistently associated with fairy circles. They argued that the patterns were too regular to be explained by plant competition alone. On the other hand, supporters of the self-organization theory used computer models to show how simple rules of plant competition could, over time, generate patterns that look exactly like the fairy circles. They pointed out that similar vegetation patterns, like Turing patterns, exist in other arid regions around the world without any help from termites. So, who is right? Well, the latest research suggests that the answer might not be one or the other. Instead, it could be both. Think of it as a collaboration. The plants, through their competition for water, might create the initial gaps in the vegetation. These small, barren patches then become ideal locations for sand termites to establish their colonies. Once the termites move in, they act as ecosystem engineers, maintaining and enlarging the circle. They keep the patch clear of any new seedlings, ensuring their underground water reservoir remains intact. This combination of plant competition and termite activity could explain both the formation and the long-term stability of the fairy circles. The termites reinforce the pattern that the plants started. It is a perfect storm of biological and ecological forces working together to create this stunning natural artwork. This two-factor theory is gaining more and more support because it elegantly explains aspects that each individual theory struggles with. The regularity and long lifespan of the circles seem to point to the termites' engineering, while the initial formation and spacing are better explained by the physics of water competition among plants. But the mystery doesn't stop in Namibia. A few years ago, scientists discovered similar fairy circles thousands of miles away in the remote outback of Australia. This was a huge surprise. For a long time, the Namibian circles were thought to be completely unique. The Australian circles look remarkably similar, but here's the twist. The sand termites found in Namibia don't live in Australia. This discovery initially seemed to deal a major blow to the termite theory. If termites aren't there, they can't be the cause, right? This led many to believe that plant self-organization must be the universal mechanism. However, further investigation in Australia revealed that other species of termites and ants might be playing a similar role, engineering the soil in their own way. So while the specific insect might be different, the underlying process of social insects modifying their environment could still be a key factor. The existence of these circles on two different continents opens up a whole new chapter in this captivating story. It suggests that this is a convergent evolutionary phenomenon where different ecosystems under similar environmental pressures independently arrive at the same stunning solution. The fairy circles of Namibia are more than just a scientific puzzle. They are a profound reminder of the intricate and often invisible connections that govern the natural world. They show us how life, in even the most extreme environments, finds a way not just to survive, but to create patterns of breathtaking beauty and complexity. Whether they are the work of clever termites, the result of a desperate battle for water, or a combination of both, they stand as a testament to the resilience and ingenuity of nature. The next time you look at a seemingly simple landscape, remember the fairy circles. Remember that beneath the surface there might be a hidden world of competition, collaboration, and engineering, all working together to create the beauty we see. The desert, so often seen as empty, is actually telling a story written in circles of sand and grass. And it's a story we are only just beginning to understand. Thank you so much for joining me on this journey into one of nature's greatest mysteries.